Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Composable data infrastructure is great until you spend all of your time gluing it back together. Bruin is an open source framework driven from the command line that makes integration a breeze. Write Python and SQL to handle the business logic, and let Bruin handle the heavy lifting of data movement, lineage tracking, data quality monitoring, and governance enforcement. Bruin allows you to build end-to-end data workflows using AI, has connectors for hundreds of platforms, and helps data teams deliver faster. Teams that use Bruin need less engineering effort to process data and benefit from a fully integrated data platform. Go to dataengineeringpodcast.com/Bruin today to get started. And for dbt Cloud customers, they'll give you a $1,000 credit to migrate to Bruin Cloud. If you lead a data team, you know this pain. Every department needs dashboards, reports, custom views, and they all come to you. So you're either the bottleneck slowing everyone down, or you're spending all your time building one-off tools instead of doing actual data work. Retool gives you a way to break that cycle. Their platform lets people build custom apps on your company data while keeping it all secure. Type a prompt like, "Build me a self-service reporting tool that lets teams query customer metrics from Databricks," and they get a production-ready app with the permissions and governance built in. They can self-serve and you get your time back. It's data democratization without the chaos. Check out Retool at dataengineeringpodcast.com/retool today. That's RETOOL, and see how other data teams are scaling self-service. Because let's be honest, we all need to retool how we handle data requests. Your host is Tobias Macy, and today I'm interviewing Jacob Leverich about how data lakehouse technologies can be applied to observability for unlimited scale and orders of magnitude improvement on economics. So, Jacob, can you start by introducing yourself?
You betcha. Yeah, nice to be with you. I'm Jacob. I'm one of the co-founders at Observe Inc. So we built an observability solution built on top of a lakehouse architecture. And kind of current day job, I guess, is CTO. But I've kind of worn almost every hat under the sun, kind of through our journey over the past several years. And maybe just a little bit more background. So prior to Observe, I was an engineer at Splunk. So I worked on the core search engine at Splunk, just banging out C++ code, scaling that thing out to bigger and badder use cases. So it was a very good experience. I had lots of great things to say about the product and the company, the technology. Prior to Splunk, whirlwind tour, big companies, failed startups. Spent time at Google, spent time at HP Labs, spent time at IBM, did the whole grad school thing. None of it matters. Kind of the thing that's like most relevant to what we do now is when I started my career late 90s, early 2000s, I was a Linux sysadmin. Just banging out mountains of Perl scripts to monitor and maintain servers, manage servers in colo facilities, or a pager, like a 4-line alphanumeric Motorola Elite. And so kind of like, lived the kind of DevOps and sysadmin dream kind of in the formative years of my career. And so, when I arrived at Splunk, it just kind of dawned on me like, holy shit, if I'd had this software as a practitioner, I would have been way better at my job. And just sort of understand like a couple of different pieces of that. It's like one is, solving the hard technical challenge of bringing together just like mountains of log data and just having, some place to go and slice and dice on it. But then the second is just sort of like having, just like solving the business process challenge, the organizational challenges. How do you get everyone access to the same data so that when you're troubleshooting at 2 a.m. when everything's gone down, you kind of all have like the same alert to respond to and the same dashboard to look at and the same data to drill into. And I started to appreciate like how valuable that sort of like data centralization platform is for the like kind of the job of like system administration or site reliability engineering or DevOps or whatever. And so and I kind of discovered there that I was actually, surprisingly passionate about this space. And so it's kind of led to founding Observe. So we kind of do a lot of similar stuff. We target software developers and SREs and IT analysts and security analysts, folks that have, these like profoundly large volumes of, sort of disparate data, but ultimately, kind of need to be able to bring it together and collaborate to solve challenging problems, answer difficult questions. And so we build a product that sort of ties a lot of this stuff together, which I'm sure we'll talk a lot more about in a second.
And so I actually share the origin story of starting as a sysadmin in the Linux space in particular. So it's interesting the journeys that you end up taking. And I guess along the path from where you were to where you are now, what would you say is the point where you actually got started in the data management space?
I'll just riff on this for a second because I think when you phrase it that way, it kind of triggered some memories in me. I mean, obviously back when the system and was doing centralized log management, so like using, rsyslog to centralize stuff, but that's kind of small stuff. I think actually when I got into grad school, I was working on computer architecture and doing lots of like large simulations of microprocessors, all these cycle accurate, microprocessors, and collecting memory traces and doing all sorts of analytics on that data. And I kind of found like kind of unique amongst all my peers in grad school. It's like, wow, like I'm generating tons and tons of data, and I'm trying to analyze all of it, and like it doesn't fit on the stupid little desktop under my desk. I actually need some like hard iron to like process this stuff. And so I kind of went through a process of just grant writing to like buy server clusters, and to start to piece together just like cruddy large distributed file systems like Gluster to like kind of like wrangle all of this data and start to build a bunch of crummy tooling to like analyze all this data. I was using systems like Torque as like a cluster workload scheduler to like start to process all this stuff. And eventually started playing around with MapReduce, kind of getting into that space, and started to just use that for my distributed data processing. And then a whole bunch of things just started kind of building on top of that. So on the basis of some of the research I was doing about the power proportionality of MapReduce, which is a very kind of a baroque sort of a topic. It's how I ended up at Google, as I was interning on the MapReduce team at Google, kind of doing basically performance engineering on the MapReduce team there. That was around 2010. And that was cool. That was like very, very interesting to kind of be kind of at the locus of like where a lot of this like very, very interesting large scale, data processing work was happening. But there's like kind of two things that I discovered during that time at Google, particularly working on MapReduce. The first was that Google had long since moved on from MapReduce in 2010. And like no one outside really knew that. And so everyone still thought like, oh, Hadoop, this is the future of data processing. And it's like, nothing could be further from the truth, So there's like all sorts of like new things happening kind of in the sort of data processing space, the parallel data processing space, kind of around that time. So that was one kind of like thing, is sort of like starting to learn that there's like more going on in this industry than just MapReduce, and it seems that there's being a very, very large reversion back to traditional strategies in the RDBMS space for data management, which is very interesting to me. And then second is that in order to do my job at Google, like to do this performance engineering work on MapReduce, what I ended up doing all day long was using a tool called Dremel, which was their internal, basically columnar scale out SQL analytics, sort of a query engine, and separation of storage and compute, and sort of columnarizing all the data it does work on, multi-stage phase execution, parallel processing, all that sort of stuff. And I started to learn about that system, and I was like, wow, this thing is amazing for processing petabytes of data. And hey, it's actually really nice to be able to express all my queries in terms of SQL, even if there's some like kind of weird idiosyncrasies dealing with this sort of semi-structured nested data. But like all things considered, that was an incredibly powerful tool that was used ubiquitously internally. And so, later on, a lot of that technology got, commercialized in the form of BigQuery. And so I got to kind of see just like kind of how a lot of the nuts and bolts of something like that were made, and sort of like what it's used for, and sort of how it's sort of blended back into, what's maybe just the more traditional, data management space. And if you don't mind, I'm going to keep going for a second here, because this story kind of like it just kind of builds like a snowball as time goes on in my career. So when I ended up at Splunk, there's actually a lot of similar aspects to kind of their use case. A large scale log data management system, and it's kind of roughly architected as a system inspired by MapReduce, where you have a cluster of indexers that all have their portion of the data. When you execute a query, it gets distributed out to all those indexers, and they do their partial search, and then it all gets aggregated by search head, and it's all a very MapReduce style of execution model. And I think what I could see there was that this was an incredibly powerful commercial tool. The users loved it. I loved it as a user myself. But it was definitely architected kind of in the pre-cloud era. This like Splunk was built in, started in 2003, and was very much architected in the spirit of a shared nothing database, where you're heavily reliant on local disk, for storage. It's doing its own replication of data for durability. And I think that the systems that were, that I sort of saw at Google were very much, cloud native. We're like, hey, we have this thing called, Google File System, that we can store all of the data in. And that means that the storage is separated from the compute. You can bring compute resources online and offline as you wish. Durability is sort of handled for you. You'd never have to worry about it. And that's very much true of Amazon S3 and kind of all of the object stores you see in the cloud today, where kind of infinite scalability and durability and low cost are just sort of like solved problems. And so the question is like, how can you take advantage of this very important building block in the architecture of a future data management system? And at Splunk, like we kind of knew this. Like we had a bunch of hardcore database folks like on the team there, and sort of me with my experience kind of working with these systems in grad school at Google, I kind of knew what they should look like to be cloud native. And so we had an awesome roadmap kind of like all the different things that we were going to have to build in order to kind of really modernize this platform. And as a technologist, I was like, man, it's my dream. Like I'd love to spend the next 10 years like, building out all this new technology. But I had a chance encounter kind of in that time period around 2016 or so. I had a meeting with the two co-founders at Snowflake. So me and the chief architect at Splunk met with Benoit and Thierry from Snowflake. And it was just the regular meeting of the minds and just chat about technology and partnership opportunities and blah, blah, blah. And in preparation for that meeting, I went off and read Snowflake's SIGMOD paper, where they described sort of the architecture of Snowflake, and kind of dawned on me like, holy shit, these guys have built our roadmap. They have built a commercial instantiation embodiment of basically all of the best technology ideas that were available at Google in terms of the separation of storage and compute, in terms of sort of how do you do parallel processing of semi-structured data? How do you do this in the form of a relational database? I mean, there's so many things there that were just sort of in my from what I saw is like we now had a commercial database that actually solves a lot of the hard scaling challenges and sort of takes advantage of the technologies available now for this use case of like the analytics and storage and management of very, very large volumes of semi-structured data. And so that kind of sparked the idea for me. It's like, wow, so what would it look like to try to build a observability system on top of a commodity off-the-shelf, cloud-native data warehouse like Snowflake. And so that's kind of like where we started to just like work through the nitty-gritty details of doing this use case in what's effectively a lakehouse architecture.
And that brings us back around to the question of observability. And before we dig too much into some of the benefits of lakehouse architectures for that problem domain, can you start by giving a bit of an overview of some of the key pain points that, in particular, customers of observability products encounter when they get to the decision point of which system am I going to use, or which open source components am I going to try to deploy? And how does that act as a speed bump to the solutions that they actually care about, which is I want to know when my systems are not behaving properly and understand how to get the information I need to be able to fix them.
Yeah, totally. I mean, I guess you and I are both like old sysadmin hats, right? So like we live and breathe this stuff. But like for folks that aren't like super familiar with the observability space, there's maybe like a couple of ways people think about it. It's like one is, hey, you're operating large digital infrastructure, whether it's applications or IT infrastructure. Well, you really just want to understand, what's going on with those systems. Are they up or down? Are they performing the way I expect them to? Am I having errors and so forth? And people, tend to deal with several different modalities of data, whether it's system logs and application logs, or infrastructure metrics like CPU usage and memory usage and network throughput and stuff like that. But then also request traces. So when a message, an API request comes into a front end load balancer, it probably talks to 5 or 10 or 100 different backend systems, and sort of how does that message get bounced around? So how do you trace kind of all those different interactions? And so there's just a large volume of this data in a modern sort of digital environment, and then there's a lot of different modalities of this data. And I think you also have like lots of different sort of, I guess, components, to digital infrastructure, whether it's, say the front end load balancer, the application server, the database server, third party APIs. There's like all these different like things that all are sort of come together to like serve an end user request. And so observability is just really, kind of like, hey, how do we actually like cope with this? Like, how do we answer questions about what my end user experience is, given this proliferation of different components and modalities of data? And what's been very common in the industry for a long time is to have a bunch of best in breed tools for each one of these modalities of data. So folks might put their logs into Splunk or Elasticsearch. They might put their metrics into Prometheus or Datadog or New Relic or something like that. They might have something like AppDynamics, Dynatrace for their application tracing. And there's like a bunch of things that come about as a result of like kind of selecting best in breed tools for these different use cases. One is that no single person at the company can answer a question. Like you end up like when there's like a real issue, you end up with like a war call from hell with like 50 people on the line, like all looking at their tool that they understand to try to come together to solve a problem. And so that's a very common experience for folks. The second problem is that these tools can be very, very costly. And so, there's sort of like premium best in breed tools. A lot of them architected, kind of in the pre-cloud native, days where you're using shared nothing architectures, you're storing all the data on local disk, you're doing replication on your own. So there's all sorts of like cost associated with these platforms. And that's whether you buy like a SaaS solution or you self-host, like you kind of bear those costs one way or another. And as a result of like kind of like the extreme cost of a lot of these tools, like people end up actually rationing their usage of them quite a bit. Well, they'll be like, well, I have all these logs, but like it's too expensive to put them in this or that, so I might as well just not. And people end up like either not having access to the data that they need to do their job or to like kind of actually troubleshoot things, or they end up creatively misbehaving by sort of saying like, well, I'll put some data in this thing and I'll put all the other data in this other thing that's like kind of cruddier but cheaper. And so it just kind of proliferates this challenge that like no one on earth can see the big picture. It's really, really difficult to like just like wrangle all of this data. And as a result, people find it very, very difficult to actually figure out like, well, how do I answer a question and how do I share this kind of dashboard with someone? Like it ends up being just a very, very challenging proposition for folks, and it sort of even further exacerbates the cost problem because it's like, man, if this stuff is so hard to use, even though I'm paying tons of money for Splunk, like I don't know if it's even worth it because it's so hard to use and so it doesn't have all the data that I need. So like, what's the point? So like, there's kind of just all this stuff that gets wrapped up that everyone seems to experience kind of when we talk to them about these use cases. And it's not just like a single like cost problem, and it's not like a single like consolidation problem. Like they tend to like feed into each other, and it's sort of just like as a result of all the constraints that people live with, these things just sort of end up being endemic. And so those are some of the sort of kind of big pain points. And I guess one of the things that's always been a reflection for me is that, I'm describing this from the perspective of the observability user, the SRE or the sysadmin or the application developer. And, they kind of experience like all these things. But you also, if you talk to like a business analyst, like they'll describe all the same stuff. They'll be like, I don't know where any of the data is. And like, oh, some stuff is in this system and other stuff is in this other system. And like, no one really knows like how to do this thing. So I got to ask the data engineering team to build a new pipeline for me so I can build this dashboard for my boss. And my boss keeps yelling at me because he never knows what's happening with the business. There's like the exact same issues exist kind of in the kind of traditional business intelligence space. And so I guess what's funny is that I always just think about like, the way that the way that I think about the problem that we solve in the observability space is that we're basically solving the same problem that business analysts have in the BI space, but we're solving it for a different user. And so we kind of need to meet their expectations, which are a little bit different than the typical business analyst.
I think that your observation of a lot of the observability systems having been architected in the pre-cloud native timeframe, many of them just at the cusp of cloud native starting to become a thing, but not all of the patterns had been proven out yet. A lot of them too are going to be architected with latency being a key consideration of, I want to make sure that I can ingest this data as fast as possible and serve it up as soon as I have it, which is not necessarily the strong suit of many of the lakehouse architectures. architectures. Lakehouses are optimized for, I want to be able to run a query across petabytes or exabytes of data and return an answer to you in something short of 24 hours, generally in the a few seconds time frame, but not necessarily millisecond time frame. And as a corollary to the pre-cloud native versus cloud native era, I think it's also worth discussing a little bit about some of the juxtaposition of architectures such as Loki, Cortex, and Mimir, and the way that they think about that separation of storage and compute as a means of better economies of scale versus the ways that lakehouse architectures are structured, particularly in the context of columnar data, and just some of the ways that cardinality poses a problem no matter which architecture you're going with. There's not really a cohesive question in there, but I guess I'm most interested in the way that you think about how you're approaching storage, retrieval, querying of observability data using these lakehouse technologies versus some of the way that these early era cloud native architectures were designed to take advantage of the economies of scale of S3 and being able to run queries against that in a relatively performant fashion, with Loki, Cortex, and Mimir being the ones that are most top of mind. And I guess Tempo is the other one that I'm aware of.
No, great. That's a great question and great observation. And so, maybe like the segue from what I was talking about earlier with like kind of the observability users' expectations and needs being slightly different than the business analyst needs. You hit the nail on the head. It's like, hey, business analysts, I'm okay if it takes 30 minutes for the data to come into the system because I'm going to run the report at 3 a.m. So I don't care. With the observability user, I need to know what's happening right now because the site's down. So like the latency and kind of ability to do kind of snappy interactive queries is very important. And so what I can say like right off the bat is that, yeah, if you try to like architect a full data like pipeline or data management solution just sort of generically on top of a lakehouse for the observability use case, you're going to fail. Like if you just like dump all the data into a big table and like expect that like things are just going to work, I'm afraid to say that they aren't. Like because for exactly reasons you mentioned, like these systems are designed for scanning, petabytes of data, and if a lot of my use cases are actually looking at the most recent data very quickly, it's a little bit different. So that's actually kind of like more or less a lot of the things that it's interesting because when I think about Splunk's architecture, like Splunk actually had to solve a lot of these problems too, because it also kind of handles like terabytes or petabytes of data and very, very quick interactive queries. And so kind of the trick for us was like, well, how do we twist a columnar analytics database into being suitable for a use case like this? And I think just thinking about it through like the like kind of stages of like day in the life of the data, from like data origination through to like an end user querying it or doing alerts, is like kind of the way I think about it. We have to kind of solve problems at each step of the journey there. Starting with like data collection, like people have like either log data sitting on disk, or they have infrastructure metrics from like their Linux box or their VM or whatever they need to scrape, and so you need an agent to like pull in that data. And so we're going to be trying to optimize for like end-to-end latency. So like I'm not going to use something just totally generic for data pipelines. Probably going to build something that is like purpose built for more sort of streaming of all this data. And so back in the day, we were just using the open source log collectors and telemetry collectors are available, like Fluent D, Fluent Bit, Telegraph, that kind of stuff. OpenTelemetry these days actually has fortunately come into its own and provided a very good answer for the industry of like what is a capable vendor neutral open source data collector that's well supported and getting lots of investment. And so we recommend to all of our customers deploy OpenTelemetry collector. Sort of here's some golden configurations you can use that you will be successful with. And we also package our own distribution of OpenTelemetry collector with a few bells and whistles on like troubleshooting and setup and stuff like that. But at the end of the day, it's just OpenTelemetry for kind of collecting the data, which in the simplest case is probably just tailing a log file off a disk, and then sending that data over OTLP, so the OpenTelemetry line protocol, to a sort of a sink, someplace to like collect this data and load it. Your typical lakehouse, doesn't have an OTLP endpoint. There's no OTLP like sort of like API for like S3. And so kind of as part of like actually solving this use case, you actually need some place to like actually receive that data and handle authentication. And so we've kind of had to build ingest APIs for serving as a destination for OTLP data, and then we load that data into Kafka, and just think about like loading data into a lakehouse. Like you don't do like row by row inserts. That doesn't make sense. You're trying to build large partitions. And so, you kind of need to buffer that data for a couple of reasons. So the first is that you want to reply to those data collectors before you've you want to reply to those data collectors when you have the data durably stored, but you don't want to rush loading the data into the lakehouse because it's going to be inefficient to load it row by row. And so what we do is we write the data to Kafka, we commit, and then we reply to the client with a 200. And so our guarantee to collectors like OpenTelemetry collector is when we send that 200, this data is now durable. We've got it. We're gonna make sure it makes it the rest of the way. So that's kind of one of the benefits to having something like Kafka sort of in that ingest path. But then the other benefit is that that's kind of our opportunity to just batch the data and right size what we end up loading into the lakehouse. And there's this just sort of key trade-off between latency and efficiency. If your batch size is too small, then you're going to be really not getting, you're not going to be running sort of your data loading jobs in sort of a throughput manner. So you're not going to amortize your overheads, and it's going to be expensive. So you really don't want to do loading too frequently. But then also you don't want to wait too long, because if you wait too long, then hey, the site's down and I don't want to wait 30 minutes to go see the logs, and so I need to load the data swiftly. And so what we've had to do with our loading is actually just build a loader that's very, very dynamic with respect to these aspects. Sort of never waiting too long before loading data. So always having good timers and being tunable with in regards to this. But then also doing everything we can to batch data up before loading it, and to try to make sure that we're loading data, tens to hundreds of megabytes at a time, so that we can get the efficiencies of sort of throughput-oriented processing and batch sizes for this kind of lakehouse loading. And I guess one of the things that's kind of interesting is that that kind of sounds like a terrible trade-off, and I don't want to wait 5 minutes to load data because I'm waiting for a 10 megabyte batch. And when it turns out with larger digital operations, the volume of data that they generate is so large that you end up getting nice sized partitions very, very quickly, on the order of 5 to 10 seconds. And so I think what we found is that our solution, our kind of technology choices and sort of lakehouse architecture, it maybe doesn't make as much sense for very, very low data volumes, if you're only loading a few tens of gigabytes of data per day. But a lot of the folks that we see that really have these challenges around high cost of all their existing observability tooling, they have tons of different modalities of data, they have tons of users of kind of have different needs for this data. They tend to be dealing with very, very surprisingly large volumes of data. And I mean, on the low end, we see customers that are loading tens of terabytes of data per day. On the higher end, we see people that are loading hundreds of terabytes of data per day or petabytes of data per day into these systems. So that's 500 terabytes per day every day, and wanting, in many cases, needing to keep it for months, and so this is very, very large volumes of data, and you're talking about gigabytes per second of throughput. And so even though the natural intuition is that it's going to be very slow and high latency to load this data into a lakehouse, the reality is that it's a throughput problem. And really the trick is actually I need enough parallel processing, throughput to just even handle the data. And the latency doesn't end up being your biggest problem. So that's kind of one of these counterintuitive things about this use case, at least at scale. And so that's kind of the loading of the data, and sort of kind of the batching, the buffering, kind of the durability, making sure it gets loaded into the lakehouse efficiently. But simultaneously, hey, you just load all the data into a single big table, and then you run your SQL statement on it. I can't wait 24 hours for the answer to come back. So you got to do something about that. And so there's actually two main tricks that sort of I think are the key to making all this stuff work. So the first is that when you're dealing with all this observability data in the raw, the OTLP data in the raw, it's you're talking about unstructured log data. You're talking about just all sorts of these JSON blobs coming out of your distributed tracing data. It's very, very raw. And in many cases, the what you want to do is either do more of an analytic query on this data. Like you want to do like a dashboard. You want to have a chart on a dashboard. So you want like some time series data. And so like, doing that over the raw data can be very, very expensive. So that's not ideal. But then also you're rarely querying like all of the data at once. Like you're usually querying the data, kind of confined to a specific use case or a specific property. Like I'm looking at my database logs, rather than all logs, or I don't want to look at my VPC flow logs. And with the scan-based like kind of data, like architecture, like a lakehouse typically is like a very much a scan-based thing. The thing you worry about is always like read amplification. Like I don't want to read a bunch of data that is irrelevant to my query. And so in a normal data management system, we would have a bunch of indexes. But with a lakehouse, you don't really rely as much on random access. That doesn't make sense when you're accessing an object store. And so the trick that we use is actually we just organize the data around use case. So rather than loading data into a single table, we go to the extra effort to sort of like curate the data around particular use cases. We put the logs over here, we put the metrics over there, we put the traces over here. Within each of those, we make every effort to kind of split it out further. Kind of say like the VPC flow log should go into this table, the database log should go into that table. And our system is very, very flexible it's basically programmable for doing that kind of data pipeline building. And we've architected this as essentially a big old streaming ETL platform where kind of, data is coming in and we immediately begin just sort of doing this sort of percolation for like the transformation, the curation, the enrichment of the data into these downstream tables that are the ones that we actually have users query. And so this solves like two key problems. Like one is it columnarizes the data so that when I want to build a dashboard on top of any of these things, that dashboard is only going to read the column that it concerns. And so that query is going to be fast. It's going to like make the best use of what you can do with an analytics database, a columnar analytics database. But the second is that it solves the read amplification problem. Sort of like we don't have indexes, but we've at least organized the data so that you kind of minimize the degree to which you're getting read amplification. And so, if you don't do those two things, you end up, kind of in a very bad profile in terms of query latency and cost when dealing with the system. But if you kind of can amortize those that by doing kind of this one-time data transformation when you load it, you can catch back up kind of with what you would get with a traditional index system. And then that's kind of the first trick, is doing this like curation, enrichment, kind of like columnarization of the data. But there's actually a second trick that we do that's very important that actually is sort of like what actually gives us a lot of the interactivity that our users expect, which is that we do not ask our users to go off and just write a random SQL query on this data. We're not doing like single shot sort of queries on this data. We've built our kind of workflows and UIs and query APIs to abstract SQL away from the user so that we can play a bunch of tricks. And so one of those tricks is that when one of our users queries data, say they query, all the error logs over the past 24 hours, our backend will actually take that and break it into a series of SQL queries, and we'll either run those like sequentially, like cursoring through time, or can even run them in parallel. And the idea is that if I'm searching for like a needle in a haystack, I kind of just want to see some results quickly. Like it's very important to like be able to like very, very quickly sort of see kind of what hits do I get, or what data do I see in the last minute versus the last 6 hours. And so we've like optimized a lot of the query execution around that sort of like urgency and timeliness of getting data out. And it's forced us to definitely kind of engineer around a lot of the typical challenges you'd face if you were just trying to run plain naive SQL queries. But again, we found that with the volumes of data we're dealing with, kind of like doing these tricks, like breaking into sequences of queries, actually works pretty well. The overheads amortize very well. We can get back results to people very, very quickly, and it's not materially more expensive than running the full batch query. And we handle all of like the gnarly mechanics of cursoring over all of the distinct result sets that are being returned by the engine. And so these are the things that we've done to like make a lakehouse amenable to this more like real-time use case with lots of heterogeneous data. And I'd say, if just kind of thinking about sort of where the technology is going and where the gaps are, I mean, I think we're clearly operating at the fringe of like what lakehouses were like sort of conceived to be able to do. And we've built certainly a lot of bespoke solutions to like overcome some of the limitations, and to great effect for our users. And I guess I'd expect over time that a lot of these strategies will generalize, and that people will begin to build sort of more general purpose query execution engines for lakehouses that incorporate a lot of the ideas that we've incorporated, whether it's handling efficient loading of streaming data, fast interactive queries. I think we've, at least from the success of our business and our customers and our unit economics and all that sort of stuff, I think, we have like the sort of proof that like it can be done. It's not easy, but it can be done,
And in terms of the overall lakehouse ecosystem, I think one of the key pieces of it that can have maybe an outsized impact on your ability to handle this streaming ingest and performant querying is what table format you build on top of. And given the time frame that you were starting, that was sort of right at the beginning of the table formats becoming a thing. I think Iceberg may have been started at Netflix around the time that you were starting Observe. Hoodie was probably in maybe the early stages of being developed at Uber around that time frame. And I'm just curious how you're thinking about the table metadata layer, the impact that that has on ingest and query capabilities, and then also in particular some of the ways that these AI native workflows impact the utility of those table formats. I'm thinking in particular about the Lance format that has native vector indexing capabilities, and just some of the ways that the evolution of the space is getting pushed by a lot of these agentic workflows, particularly with things such as AI-powered agentic SREs and things like that.
Yeah, you're absolutely right. So when we started, Iceberg wasn't really a thing yet. If I remember correctly, Snowflake GA'd in 2015. They published a Sigma paper in 2016. It had a lot of like core ideas in the space. I think Netflix published the Iceberg spec in 2017. And so, yeah, it's kind of like all this stuff is happening right around the time we were founded. And Iceberg, kind of in 2017 was like, it was like, actually, I remember learning about it right then. It was like, wow, this is amazing. Like, this is like a lot of the things that Snowflake does, but it was still obviously very early days for it. It's like there's no vendor support clearly at that point. And so, we kind of just as a circumstance of like the moment in time, kind of we chose like kind of the best solution available at that moment, which was Snowflake, which it's interesting now when you think about like just the degree of overlap between Snowflake's internal table formats and Iceberg, being built with the idea that the data is going to be stored in commodity object storage, the idea that you're going to maintain, metadata for columns so that you can do partition pruning efficiently versus what you used to have to do with Hive, the idea that everything's going to be built around a kind of snapshot isolation model, so that kind of it's very easy to provide consistent views of the data and to handle things like schema evolution, all that sort of stuff. I mean, like it's just so funny because like you can read the Sigmod paper from Snowflake and you can read the Iceberg spec, and you can like they like hit all of the same bullet points. And so this has always been just like a totally apparent, kind of for me as like a the solution vendor building on top of a database like this. It's like, yeah, there's like very, very there are commonalities to all this technology, and sort of where does this stuff go in the future? And I think what's very, very exciting now is to see the degree of industry adoption of these table formats. And I think Iceberg, what sealed it for me was when Amazon announced that S3 tables was going to be based on Iceberg. That sort of like was a clear indication that like, yeah, these guys, that Iceberg is going to be a fixture in the data management space, and we can start to make bets on it. And meanwhile, fortunately, I think that both Snowflake and Databricks saw that like kind of trying to build their own silos, and silos is like maybe too harsh of a term because I know Databricks has always been open source to respect this stuff, but it was clearly like a vendor specific, sort of a thing. Once we saw like both Snowflake and Databricks start to really lean in on Iceberg, it was kind of for us that meant is go time. It's actually like go time to start like actually figuring out like what do these table formats mean for the future of data management for observability. And there's a couple of things that I could see, and we're acting on actively now. So one is that in all of my conversations with data officers and CIOs and CISOs and stuff like that, like everyone like wants to consolidate around a common sort of data strategy for a large enterprise. And a lot of times like the companies just want to be, basically they want to own the data. They want the data to be in their data lake. They want it to be in formats that they can take advantage of. They want to load the data once and use it for multiple use cases. And so kind of like the emergence of these open table formats that have like real vendor support actually is very, very important, because it means that is now a reality. You actually can begin to ideate about doing things like that. And the second was, we've proven out that we can do the lakehouse architecture for observability using Snowflake's proprietary table format. Well, is that going to hold as we move to a future world where we're using non-proprietary, sort of table formats, we're using Iceberg or whatever? And so fortunately, we've had very, very good relationship with Snowflake for a long time. So we were able to get early access to kind of their development features for Iceberg. And we've been benchmarking the ever-living crap out of it and kind of taking all our different use cases and trying to analyze the different ways in which we process data. And our experience has been that Snowflake's implementation of Iceberg is essentially at parity with their proprietary table format, which is like, it's just a huge win for everyone. It's a huge win for us. It's a huge win for our customers. I think it's a win for Snowflake. They can participate, in this open data ecosystem and sort of the vision and direction that large enterprises want to have with their data. And so I think it all kind of goes back to like Iceberg and Snowflake. Kind of a lot of the technological principles underlying those table formats are very, very similar. And in my experience, it follows through with the actual performance and efficiency outcomes we're getting with it. And so we have now features in our solution where we can selectively store data in Iceberg format rather than Snowflake tables. We can ingest data directly out of Iceberg and just read it and do searches on it directly. And we're kind of building towards this world where all data that we load and process, kind of is Iceberg, kind of in customers' own data lake, their own S3 bucket in an open table format. Kind of our idea is it's your data in your data lake in an open format, sort of like the vision that we aspire to for this solution. And that also opens up like kind of interesting new opportunities. Is it like, hey, I described earlier like our ingest pipeline, everything we do to load data into Iceberg, and that's kind of stuff that we've tuned for our use case, and it's stuff that we've done for loading our data. But also like folks are, at the same time, they're going to be building their own data pipelines. They're going to be coming with their own strategies for loading data into Iceberg. I think kind of as we get into this more like open, data lake ecosystem, I think it opens up opportunities for people to do things like in the data collection agent, rather than sending, kind of like OTLP data to some API endpoint to then, buffer it and load it into a lakehouse. Well, maybe that data collector can go ahead and make, Parquet files directly, and then you can just just load them like directly into the S3 bucket, or you can copy it through an S3 endpoint or something like that. I mean, there's probably like lots of ways in which to like just start to kind of even further reimagine sort of like how data is loaded into a lakehouse and how you can sort of either distribute the computation that goes into it or further optimize the cost profile of it or a customer's autonomy sort of over how data is loaded. And so I think as you can tell, I'm very excited about all the different stuff that's going on in the Iceberg system. I think it's very compatible with like kind of our vision for like what the observability user needs. Thankfully, it's very compatible with the vision that, kind of the traditional data needs of a business. And so there's lots of synergy and sort of a tailwind behind this technology right now. And so we're kind of all over that. I think it's kind of just the trend. It's the direction things are going anyway. And then I wanted to touch on, you kind of mentioned this AI topic, kind of what else does this mean for like AI and stuff like that. And I think a lot of our perspective on it has been for a long time, you can only use AI to ask questions about data that you have. And like all of these like sort of challenges that people have faced with like best of breed tools in the observability space in the past, where they have some data over there and some data in this system and some data in that system. And they're trying to like, build together, sort of some agentic reasoning workflow to deal with all that data. It's like kind of a disaster if it's like all spread out everywhere. I guess the way I sort of just dream about this is that like as more and more of this data is centralized into the lakehouse, it's sort of like much more practical to imagine that I actually will have the data that I need in order to build this workflow. I don't have to go hunting for it. And then, the last part of it is, I think, kind of is that topic we touched on earlier, which is that, everyone's always concerned about the speed and maybe the cost of like accessing data out of a lakehouse. I guess what I've come to, just experience building our product is that when you go to the effort of actually organizing the data like we have in a lakehouse, where you sort of like split it out on a use case by use case basis and you go to the effort of columnarizing it, it can actually be very, very cost efficient and performant to query data, even if, kind of it's sitting at rest in S3. And the last thing that we kind of realized about like kind of that strategy of like organizing the data is that we did a lot of it for reasons of like making the lakehouse architecture work, but then we also did it for the purpose of making it easier for a human to work with this data. I don't typically want to just ask questions about my raw logs, and I certainly don't want to query like all of my logs. Like I typically have some use case in mind when I'm going off and dealing with this data. I have a user who reported an issue and I want to go see the logs for that user or the kind of health metrics for that user or whatever. And so I always like have like a use case in mind when I'm kind of like going off and interrogating one of these systems. And so when we started to like build all these this streaming ETL platform and sort of divide data into all these different tables, like very much the idea was, let's organize the data around a use case, because that's going to be both which makes the lakehouse architecture work, but it's also going to make it easier for a human to find the data that you're looking for, because it's now organized around concepts that they're familiar with. And when we started building our AI capabilities, we kind of just like already had that like curated sort of graph of the data, if you will. And so now of course we call it the context graph. But we do like just little tricks. Like we make sure that when we do our context engineering, we know the schema of all the data. We have descriptions of all the different columns. We load in, descriptions of the metrics that are in our system. When we go off and run our agentic workflows, like the first thing it's doing is like figuring out, okay, what is a natural language question that a user asked? And then, hey, like let's do some vector search on all of the metadata about the data I have in the system. Let's find the right data that may be applicable to the question they're asking. And then kind of with that whittled down set, that's the thing that we do our query generation on, and then ultimately answer this natural language question. We found that the curation of the data not only made it, more easy to use for a human, but it made it more efficient and more accurate for an LLM agent to work with the data as well. And so I think curiously, like kind of all the things that we do to make a lakehouse effective for a specific use case is also what makes an AI effective on sort of data that's hosted in a lakehouse as well. And then just to kind of like, I guess, go back full circle with that, it's like you can only answer questions about which you have data. And so kind of if all these things come together in a world where I actually do have this like trusted centralized repository of all of my data, and it's at least roughly curated so that the AI or the human can go off and navigate it, then we can actually extract some value from it. So sorry, long-winded way to answer a question, but that's right.
No, that was great. And I guess briefly, one of the key elements in there is roughly curated, because one of the challenges of data lakes in particular that led to the creation of these lakehouse architectures, which is also a challenge particularly around some of the labeling and cardinality management of logs and metrics and traces, is that entropy will win if you don't fight against it. And so you can have all of the data, but to a point you made earlier, it's completely useless if you can't find it or understand which data you need for which problem. And I'm wondering if you could just talk to some of the guardrails that you think about factoring in Observe, or just broadly in some of these architectural primitives that help to guard against the effects of entropy in these lakehouse architectures for observability systems.
Yeah, great question. So there's really like two things that come to mind right off the bat. So one is that one of the thankful things of sort of building our solution in the context of a specific use case is that we can kind of be prepared for a lot of like use cases right out of the box. And so if someone has like logs from their AWS like Lambda that they want to like do analytics on, like we've seen that use case 100 times, so like kind of we already have sort of out-of-the-box pipelines for organizing that data and for making associations between, sort of the right CloudWatch log groups and the right ARNs for the Lambdas and all that, sort of jazz, so that people can like work with this data and no one has to really worry about it. And so I'd say there's like an 80% of a use case that like we just sort of handle out of the box, and so people don't need to worry about it. And sort of like the benefit of being a vendor in a particular context is that we can bring our expertise to bear on that. But then there's naturally just it's what I do with the other 20%, and more importantly, like all the infrastructure stuff is great, but like my business is unique. One of our customers is Topgolf, and like they have like tons of I don't know if you know about Topgolf. It's like kind of this entertainment venue with like golf driving range, and they have venues and they have bays and they have these kiosks with games and all this sort of stuff, and they have a support desk where like, hey, if one of the like kiosks breaks down, like now like, oh no, we need to like refund this customer and we need to like figure out what to do about it. We need to figure out if it's like a common problem with this kiosk or if it's like one off, and so their questions are all about kiosks and bays and venues and customers and things like that. Their questions aren't about their low-level logs. And so we thankfully kind of have built this system that sort of is designed for doing that kind of curation. We've built into our UIs sort of very, very like easy to use tools for building these types of data pipelines and to build these types of entity models and relationships between data and the curation of the data. And we did that partially to make the lakehouse architecture work, but then also just to try to address these use cases head on. And I think that the thing gets kind of typically challenging with data engineering is that like when you want to build a data pipeline like that, like that's not like a trivial exercise. Like in terms of like just like actually like what are you going to use? Are you going to use dbt or like what like how are you going to actually engineer this whole thing, and how much expertise do you need to do that? And if you're dealing with very, very large volumes of data, how do you handle like full refreshes versus incremental updates and all that kind of stuff? And so our platform sort of being built from the get-go to like dynamically build these types of pipelines and to handle very, very large volumes of data, we've had to like kind of build in a lot of strategies for dealing with those things. And so for an example, when you build a data pipeline in Observe, you use our query language. So the same query language you use for building dashboards is the same language that's used for building a data pipeline. The whole language is like very much built around the streaming semantic. And so kind of for whatever expertise someone uses, like kind of interrogating the data, like they're kind of halfway there to start building data pipelines. And that's very different from the typical experience, building like a SQL-based data pipeline or a Spark-based data pipeline. This is kind of like a slightly different way of doing that. The second is that, we've kind of built things, again, very much along a streaming semantic, which means that when you build a new data pipeline, it's by default go forward, and so kind of like we'll process like data going forward based on sort of this new pipeline. And so the expense of like rapid iteration is very low. And so we find that people kind of like get to success very quickly just by like kind of building a simple pipeline and just like, kind of just like continuing to curate it and kind of do extractions in different ways. And we try to optimize around just like fast interactivity for that stuff, kind of being able to save those pipelines. And so that actually makes the kind of the entry cost to building a data pipeline much lower in our solution. And it's very much geared towards like the observability user, but like it's sort of, I think sometimes I show this to traditional business users and they're like, I wish I had this. But then because everything is built in terms of our query language with the streaming semantic, we also have the ability to selectively backfill the data. And so kind of after you've arrived at like a good shape, kind of like this curated view of the data, you can go back and say, okay, cool, and I'll go backfill this for the past month. And we can, tune like, how fast do we want it to go, or do we want it to just like slowly process that data? And we can decide which size Snowflake warehouses to do that stuff. And so we've kind of had to just in terms of practical matter, deal with a lot of the challenges around the evolution of these data pipelines. And I think just kind of doing it in the context of a real-time interactive use case like observability has like forced us to like really reckon with like what does it mean to like do this stuff quickly? What does it mean to do this stuff without being a data engineering expert? And sort of we found like a few, I'd say, interesting design points in this space that aren't readily available kind of throughout the industry that I kind of expect we'll see over time.
You're a developer who wants to innovate. Instead, you're stuck fixing bottlenecks and fighting legacy code. MongoDB can help. It's a flexible, unified platform that's built for developers by developers. MongoDB is asset compliant, enterprise ready, with the capabilities you need to ship AI apps fast. That's why so many of the Fortune 500 trust MongoDB with their most critical workloads. Ready to think outside rows and columns? Start building at mongodb.com/build today. And as you have been building Observe and evolving it and scaling it, what are some of the most interesting or innovative or unexpected either ways that you're seeing it applied or outcomes that you've seen from teams not being constrained by some of these questions of economics or scale?
Good question. I think maybe one of the things that's been more surprising to me is the kind of different users that can all be successful on the solution. And I think maybe there's an obvious version of this, which is security analysts and application developers. In many cases, they want to look at the same data. And the difference with the security analysts is that they typically want to investigate something from a few weeks ago, or they want to do an evidence check from, for a compliance, sort of audit. They need to do an evidence check for 6 months ago. And so they have very different retention requirements. And so us offering a solution that kind of does both of those because it's all stored in a lakehouse and retention is very affordable, is kind of maybe an obvious one. But I think the less obvious one is that we see a lot of people with product support teams that get a lot of joy out of using our solution. And I guess a lot of these product support teams, they're sort of serving in many cases as sort of a front for sort of engineering teams. And the more that a product support analyst can answer a question or can troubleshoot an issue and hand either a designed issue back to an engineering team or can divert an issue from the engineering team altogether, that's a benefit. And so having multiple teams have access to this data, it definitely seems to be a productivity boost for everyone, which is really, really cool. And then I think what's been further, I guess, surprising is just, I don't mean to hop on the AI bandwagon because I'm kind of a natural skeptic about most things in life, but what I've seen our users do with very, very simple agentic workflows to answer questions is kind of starting to become surprising. And I'd say it started, around about the first quarter of last year when we started to see some of the newer foundation models come out. And those things are just a little bit more capable at just sort of reasoning workflows. And one of the first things we did is we made an MCP server endpoint that you could hook up Claude to. And we just started asking open-ended questions and gave it a few tips about how it could query our data. And it was amazing what it could do in terms of navigating our context graph and sort of generating the queries. And so we've just been continuing to build upon that. And then, so now we have support analysts who, know nothing about, IT infrastructure or log analytics or anything like that. And they can go off and ask detailed questions about what error did this user experience? And the thing will just go and figure that out. And we've seen now sort of quantified evidence from our customers about what that means for them in terms of how many support tickets they don't have to send to the engineering team. It's I guess a ticket diversion kind of question. They can handle more of the tickets in-house than they could previously. And we've had customers send us quantified evidence of the lift that they're seeing based on kind of being able to do it, kind of using our system and also using our system with the AI. And so I guess what I never expected to see was this quantified evidence of the productivity boost and the MTTR impact that our solution would have. And I think it's always been the holy grail in kind of observability and monitoring systems to have this clearly quantified MTTR or productivity outcome. But in many cases, it was very hard to spot it. But we're just seeing it being used in circumstances where you actually can quantify these things, and we're getting that evidence. And it's wow, this this actually did have a lift for this business. Wow, that's it's so easy to see what the business value is for our solution. And it's more than just kind of a lot of really cool technical mumbo jumbo that I love and can talk about all day long. It's actually I can see why this actually matters. And it's kind of like just a fun journey, kind of, I guess, building a startup and getting to, having a bunch of customers and tens of millions of dollars in AR, is that we're actually sort of seeing just sort of the real like business and personal impact that our technology has on users. And I guess I obviously, you always want to get there when you're building a startup, but like, I'm a technologist at heart. So it wasn't like the obvious like thing on my mind, but like at this stage, it's just so cool to see it come first full circle and kind of see the impact that our solution has in the wild. And you asked the question, like, what's surprising? I guess I just, it maybe it's just like gratifying to sort of see our technology work. And I'm just kind of thrilled by all of that.
And in your work of building Observe, investing in these lakehouse patterns for observability data and understanding the technological elements and user experience around that, what are some of the most interesting or unexpected or challenging lessons that you learned in the process?
So I think maybe it's abundantly clear in hindsight, but it wasn't totally obvious to us when we first started. I think when we first started, we were very much focused on a lot of the technology challenges of using a lakehouse architecture, and so we had built a kind of like fairly generic user experiences for like querying data and building charts and building alerts and stuff like that. But and we also kind of built this experience that like, well, there's lots of different data sets in the system, and that's like a little bit different than the typical user experience when you're using Elasticsearch or Splunk or something like that, where you just go in and grep all your logs. And I think, I've kind of mentioned that like kind of a lot of what we do is like we bring this technology, though, this like kind of modern data management technology to the observability user, and they've never really had access to this technology before. But I think the thing that I didn't quite appreciate as much in the very early days is that, well, you also got to meet your users where they are. So they're used to experiences like Elasticsearch. They're used to query languages like Splunk's language. They're used to query languages like PromQL. They're used to building dashboards like they do in Datadog. And kind of when you're trying to build a solution that appeals to a user who has probably had experience with some tool like that in the past, anything that you do that is idiosyncratic or sort of like doesn't necessarily quite meet their just like out of the box expectation can be a real burden to their adoption. And even if you can give them sort of like the cost outcome they're looking for, the retention outcome they're looking for, the performance outcome they're looking for, any of these kind of things, like, if that kind of like first impression isn't one that they're expecting, if the new car smell, isn't kind of a smell that's appealing to them, that can slow down adoption. And so, so it took us a while to like really like figure that out. And it took me a while to like really talk to enough like end users and sort of like get hints that people were struggling to do basic things like search their logs. And so, kind of a question for us just came at some point. It's like, okay, so we've got enough feedback now that people are like kind of not necessarily seeing us as a kind of like a log search experience that they expect to see. So what do we do about it? And so we kind of had just a moment where we had to like check our ego for a second. We had to start saying like, hey, our solution isn't just about building data pipelines and building this lakehouse architecture. Like, our solution is about making it easy for users to search their logs. And we built a handful of user experiences in the product that would be very familiar to users coming out of Splunk or Elasticsearch or Datadog or Grafana. And the idea was to kind of give people this like gentle, familiar on-ramp into our product so they could come in and sort of be, like, oh yeah, oh, there are my logs. I know how to search this. This all like works as I expected to. And then, over time, they would then come to realize it's like, wow, this doesn't just have my logs, it has everyone's logs. Wow, this thing is actually fast. I can query 30 days worth of data, no problem. Like, we kind of like had to set up an environment where people could discover all of the benefits of what they get out of a lakehouse. And I think just like meeting users where they are, again, kind of given their context and what they're expecting to do with this thing and what they've used in the past, turns out to be very, very important for, kind of like making a lakehouse architecture work for a particular user segment. And it's obvious in retrospect, but it wasn't obvious to us when we kind of started at the very beginning. And so, so that was a lesson we learned. And as soon as we started to release those user experiences and sort of really position ourselves in that manner, I have our MAU graphs And I'm always obsessed about like our user growth and stuff like that. And there's just like a marked like inflection point at which, kind of we started to GA these capabilities and our user adoption went through the roof, particularly in customers that we already at. And so just sort of the natural organic user adoption went up. And that was when we knew that like, oh, wow, this was an important thing to do.
And as people are evaluating which observability solution to use or what style of architecture to build on top of, whether commercial or open source, what are the situations where you would advise against using a lakehouse pattern or Observe specifically?
Yeah. I mean, I think probably the biggest inflection, the kind of biggest like point dimension that this cleaves on is on scale. If you're dealing with like fairly low volumes of data, it'll fit on your laptop. Like, don't worry about it. like it's not, maybe it fits in memory, like that kind of like there's even any of the open source solutions are actually going to work pretty well for this. They're obviously easy to set up. You can kind of begin to understand what value you can get out of your telemetry data. I'm always happy to encourage people like, yeah, play around with Elasticsearch, play around with Loki. If you want to throw your logs into ClickHouse, feel free. I mean, like definitely there's lots of solutions for kind of starting early on, kind of working with this data. And I think particularly like a lot of like kind of the smaller scale deployments, it's also naturally endemic to like earlier stage companies and earlier stage businesses where you just like don't really have like the hundreds of people trying to collaborate or something, or you don't have like just all of the different variety of data. You probably have a simpler context. And what goes hand in hand with that, like kind of earlier stage company or simpler context, is that you probably have bigger fish to fry than like your observability strategy. Like you need to make sure that your business works. You need to make sure that your products work and that your users happy. You might even need like, sort of user analytics tools before you really need something to do like hardcore observability data management. And so I would say, kind of early stage, just pick whatever feels natural. Don't spend too much time on it. Kind of make sure that you're working on the right problem. Make sure that your business is focused on the right things. And then when you start to scale and when you start to like hit these like hard decision points where you're like, wow, this used to work in Elastic, but like I'm spending, 2 full-time people just keeping the thing running now. And that doesn't seem like it's an efficient use of like capital, like kind of once you start to feel like you have to start rationing things or you're spending too much effort to manage it, that's probably when you ought to start looking at a vendor solution. And you might want to start considering an architecture that can scale to that data volume. And that's just kind of a common story I hear from like a lot of our customers, is that like they are perfectly successful at early stages, kind of with whatever technology they pick, because their use cases and needs are very modest, and they probably have more important things to do. But then there's sort of a scale point that they hit where it's just like it becomes overwhelming and they've made hard trade-offs, or they're already starting to send data into different silos and they're spending just unbelievable amounts of money on this stuff. And that's usually when someone like us can come in and just sort of like help like sort of, I guess, guide people towards like, maybe there's a different way to do this. Maybe we can help you out with like all of the negative consequences you're starting to feel with the scale. So scale, I think, is like kind of one of the big things, either in terms of data volume or in terms of just sort of like the organizational complexity, lots of different teams, acquisitions, stuff like that.
Are there any other aspects of the work that you're doing at Observe or just the overall space of lakehouse architectures for observability data and some of the capabilities that it unlocks that we didn't discuss yet that you would like to cover before we close out the show?
No, not really. I think maybe there's just like one, like just on the technology front, I think the one kind of space that's like we're seeing a little bit of innovation in is like, just how do you build solutions for needle and haystack, search, on top of a lakehouse, sort of like it's all well and good to columnarize the data, but if you want to pull out just a needle, you might need something more than just column metadata to do that. And so there's interesting stuff happening in that space. It's something we've developed solutions in. We know other folks are developing solutions in that space. Snowflake's kind of built their search optimization solution. There's sort of all sorts of like interesting stuff there. And so I think it's just such a really interesting space. I think we're definitely, at least like, for me and Observe, we're living on the fringe of this technology right now. And so I would say just pay attention to all the people working on the fringe and sort of like the challenges that they're kind of addressing these days. hopefully in the next, 3 to 5 years, a lot of the challenges that we encounter become sort of commodity generalized solutions, and everyone can take advantage of them. And it's sort of, when you think about your future planning, like if people are dealing with these problems now, then you can anticipate we're going to have good solutions to them in like 3 to 5 years. And so when you just think about your overall technology strategy and sort of what technologies you want to incorporate in the future, just keep in mind that this is a fast moving space. A lot of the problems that you might intuitively feel exist today, they tend to get solved sooner than you expect. So that'd be it.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap of the tooling or technology that's available for data management today.
So, I think it's actually, I guess that's funny. If you'd asked me this question like 3 months ago, I would say it would be the shredding of semi-structured data. Like an Iceberg, it sort of the Iceberg V1 and V2 specs didn't really have the support for automatically columnarizing JSON data. And I think that's one of the things that really held Iceberg back for a long time from use cases like observability, because a lot of the data you're dealing with is basically JSON data. Like metrics, labels, it's basically a bag of JSON key values. Same with OpenTelemetry, sort of tracing attributes, it's sort of a bag of key value pairs. And the fact that those wouldn't be columnarized in Iceberg was, I think, the thing that was holding it back from this use case. And it's one of the things that made Snowflake especially effective for this use case, because it does automatically columnarize JSON data. And the fact that Iceberg v3 now supports shredding, it supports subcolumnarization, however you want to call it. That's actually a major unlock for the industry. And so I'm kind of anticipating sort of a surge in sort of at least observability solutions built on Iceberg as a result of Iceberg v3. And I would anticipate that it's going to affect a lot of other sort of use cases and segments as well. So it's very exciting stuff. So I think that was the biggest gap that was just plugged.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing at Observe and some of the technological challenges and architectural patterns that you found and iterated on to build such an interesting solution for observability data. It's definitely a very critical area that a lot of teams need to be able to have as a reliable substrate for their work. So I appreciate all the time and energy that you're putting into that. I hope you enjoy the rest of your day.
Yeah, thank you so much. I really appreciate this and great questions. So thank you so much.
Thank you for listening, and don't forget to check out our other shows. Podcast.init covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.